Okay, so imagine this for a moment. I'm going to show you 10 ideas from quantum physics, but there's something almost nobody tells you. A lot of people take these ideas and use them to explain their lives, and they end up completely wrong. Not because the physics is wrong, but because the interpretation is. And that's dangerous, because when you misunderstand something that sounds deep, you start justifying decisions that aren't actually helping you. And the worst part, you don't even notice. So before we begin, I need to make something clear. Quantum physics describes the behavior of subatomic particles, electrons, photons, quarks. It does not describe people. It does not describe decisions. It does not describe destiny. What we're going to do in this video is different. We'll look at what physics actually says, what behavioral science actually says, and when something is just an analogy, I'll tell you explicitly. No dressing it up as something it's not. Paradoxically, that makes this much more useful. Think about this for a second. How many times have you felt like you're doing the right things, but nothing changes? You work, you try to improve, you think harder, and still, same place. Number 10. Planck quanta and nonlinear change. In 1900, physicist Max Planck was studying radiation emitted by hot objects. There was a major problem known as the ultraviolet catastrophe. Classical physics predicted infinite energy at high frequencies, which made no sense. Planck solved it with a radical idea. Energy isn't continuous, it comes in discrete packets, quanta. He didn't even believe it was physically real. He thought it was just a mathematical trick. Then, Einstein came along in 1905, took it seriously, used it to explain the photoelectric effect, and won a Nobel Prize. Now, does this apply to your life? Directly? No. Quanta exist at subatomic scales, not in your decisions. But there is something in human learning that behaves nonlinearly. Psychologist Anders Ericsson showed that skill development doesn't happen smoothly. You get long plateaus, followed by sudden jumps. Why? Because your brain is reorganizing before performance improves. In neuroscience, that's called learning consolidation. So if you feel stuck, it doesn't always mean nothing is happening. Sometimes something is building. But here's the key: repeating the exact same thing, expecting different results, has no basis in physics or psychology. Change usually requires a different variable, not just more effort. Number 9. Quantum superposition and habitual decisions. In quantum physics, superposition is real. A particle can exist in multiple states at once until it's measured. The famous double-slit experiment shows particles behaving as if they pass through two paths simultaneously. Humans don't work like that, but behavior does have something interesting. Psychologist Ellen Langer found that most daily decisions aren't actually decisions. They're automatic patterns. A Duke University study estimated that around 40% of daily actions are habits. That means most people aren't choosing from scratch. They're choosing from the past. So when you feel like you don't have options, it's often not reality. It's repetition. Understanding you have options isn't enough. You need to change the conditions that allow different behavior to happen. Number 8. The observer effect and attention. This one gets misused constantly. In quantum physics, the observer effect does not mean that your thoughts change reality. It means that measuring a system requires physical interaction and that interaction changes it. The observer is not consciousness, it's an instrument. There is zero scientific evidence that thinking positively changes external physical reality. But there is something real. Your attention changes your behavior, and your behavior changes results. A study in psychological science showed that visualizing the process of achieving a goal improves performance, while visualizing only the outcome actually makes it worse. And your mental state matters. Under stress, your brain shifts into survival mode. The prefrontal cortex, responsible for planning and decision making, becomes less effective. So, no, observation doesn't change quantum reality, but the state from which you observe does change what you're capable of doing. And that changes outcomes. Number 7, uncertainty and analysis paralysis. In 1927, Heisenberg showed that you cannot know both the exact position and momentum of a particle simultaneously. Not a technical limitation, a fundamental one. That doesn't apply to your decisions, but something else does. Barry Schwartz showed that too many options don't improve decisions, they make them worse. More anxiety, more regret, more paralysis, and waiting for perfect certainty, that strategy fails consistently. Herbert Simon called it bounded rationality. Humans don't optimize, we satisfy. We make decisions that are good enough with limited information. Uncertainty doesn't disappear if you wait. Sometimes, action creates the clarity that thinking never will. Number 6, entanglement and your environment. Quantum entanglement is real. Two particles become correlated in ways that persist regardless of distance. It's one of the strangest phenomena in physics, but it has nothing to do with human relationships. What does matter is social influence. Solomon Asch showed that people will give wrong answers just to conform with a group. Christakis and Fowler found that behaviors like obesity, smoking, and even happiness spread through social networks, up to 3 degrees of separation, not physically, socially. What your environment considers normal defines what you think is possible. That's not quantum, that's human. Number 5, time and the cost of not deciding. No quantum physics here. And that's intentional. In economics, there's a simple idea: opportunity cost. Every choice excludes others, and not choosing also excludes things. Inaction is not neutral. Daniel Kahneman showed that we fear losses more than we value gains. So, we stay where we are, even when it's not working. But while you wait, things change, opportunities close, skills decay, relationships weaken, time moves in one direction, and it doesn't wait for you to decide. Number 4, environment as a structural variable. In physics, systems evolve based on initial conditions and environment. In psychology, the same principle holds. Albert Bandura showed that we learn by observing others. B.J. Fogg demonstrated that changing your environment is often more effective than relying on motivation. Move fruit into sight, you eat it more. Move your phone away, you use it less. Not because your intention changed, because friction changed. Environment doesn't just influence behavior. In many cases, it determines it. Number 3, repetition and automatic behavior. Habits are not abstract. They are physical patterns in your brain. Anne Graybiel's research showed that repeated behaviors shift control from the prefrontal cortex to the basal ganglia, making them automatic. That's efficient, but it also means that unhelpful patterns become automatic too. Cue, routine, reward. The loop runs, whether you notice it or not. And breaking it doesn't happen by willpower alone. It requires changing the conditions that trigger it. Number 2, sudden change and thresholds. In physics, phase transitions happen when a system crosses a threshold. Water stays liquid at 99 degrees Celsius. At 100 degrees Celsius, it changes state abruptly. In human systems, something similar happens. Long periods of no visible change, followed by rapid transformation. Not magic, not quantum, but when you analyze real change, 3 things show up repeatedly: a break from the previous environment, a new variable introduced, a decision moment that wasn't gradual, it was decisive. Which brings us to the final point. Number 1, the real problem isn't information. This is the uncomfortable part. If you made it this far, you understood everything. You can tell physics from analogy. You see the role of habits. You understand the influence of environment. But that's not the question. The question is, what are you going to do differently tomorrow? Because understanding and action are not the same thing. Leon Festinger's work on cognitive dissonance showed that people can hold conflicting beliefs and still not change behavior. People don't change because they lack information. They change when the cost of staying the same becomes too high, the environment makes change easier, or the behavior becomes socially reinforced. No quantum theory will do that for you. What can help is something much simpler and much harder. Identify the pattern you're repeating. Identify the condition that sustains it and introduce a variable that actually changes it. Not more of the same, something different. Quantum physics is fascinating and it's real, but it describes subatomic particles, not you. You are described by neuroscience, behavioral psychology, and most importantly, by what you do next. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.